Hello everyone, welcome back to another video. Now in this video we are going to go through some high order thinking questions for related rates. So today we're going to solve these questions you see in front of you. Now for the first question there was like a printing mistake over here. The radius is basically square root of 34. So we're going to use that in our solution. So in this problem, they told us that there is a Ferris wheel with a radius of square root of 34 meters as Jenny, whose eye level is at 0.3, watches her friend Amanda ride in one of the cars as the wheel turns. Let Z denote the distance from Jenny to Amanda's car. So basically this is the Z distance I'm looking for. The diagram indicates the center of the Ferris wheel at the point 10, 8. So the coordinates of this center over here is 10, 8. And the position of Amanda's car at the point x, y. If x and y are functions of time in seconds, what is the rate of change of z when x is equal to 15, y is equal to 11, and the rate of change of x is equal to 1? And then they asked us to use the equation of the circle to solve this question. So the first thing that you have to do in this type of question, first of all, whenever they ask you like a related rates kind of problem, you need to know how to relate your variables together. And since they are talking about distances, so I believe they want us to use the distance formula. So the distance formula, which is going to be denoted with z, because it's the distance from here to here, it is going to be the square root of the x that I have over here. So x minus 0 to the power of 2 plus y minus 3 to the power of 2. Now we can easily find the derivative of all of this because this can be written as x plus y minus 3 x to the power of 2. Hold on. So x to the power of 2 plus y minus 3 to the power of 2, all of it to the power of half. That is basically equal to our z. Now, if you derive z with respect to time, using chain rule, and it's just one humongous chain rule over here, b half is going to go down, and then whatever inside is going to be the same, but it's going to be to the power of minus half, because you deducted the old power by 1. And then according to chain rule, you have to multiply by whatever is the derivative inside. So inside, the derivative is going to be 2x prime plus 2y minus 3y prime. Now, this is basically going to be our dz over dt. Now, if you look over here, we have our x, since they gave us that x is equal to 15. We have our y, which is basically equal to 11. And we also have our dx over dt, which is basically equal to our x prime. But now we need to find y prime. And this is where we need to use the equation of the circle, because the equation of the circle will identify for us what is our y prime. So the equation of the circle is x minus 10 to the power of 2 plus y minus 8 to the power of 2 equals to 34. Deriving this equation, you're going to get 2x minus 10 x prime plus 2 y minus 8 y prime equals to 0. I guess it's a little bit late to tell you right now, but x prime and y prime are basically like dx over dt or dy over dt, but I believe you know it by now. So let's continue. So now you just put the numbers all in its rightful place, and then you're going to be finding y prime in no time. So x is going to be 15 and x prime is going to be 1. So let's replace them. 15 minus 10, 1 plus 2, 11 minus 8, y prime equals 0. 15 minus 10 is going to be 5. 5 multiplied by 2 is going to be 10 plus 11 minus 8 is going to be 3 times 2, which is going to be 6. Now 6y prime is going to be negative 10 divided by 6 divided by 6. and then you're going to have your y prime equals to negative 5 over 3. So now we have our y prime, and it's easy for us to plug in this equation over here. So now dz over dt is going to be equal to half, open brackets, it's going to be a long one over here. X is going to be 15, so it's going to be 15 to the power of 2 plus the y is going to be 11. 11 minus 3 is going to be 8. To the power of 2, it's going to be 64. All of it to the power of minus half. And then we're going to have our chain rule effect over here. So 2 multiplied by 15, it's going to be 30 multiplied by 1, so it remains 30. And then we're going to have 2 multiplied by y minus 3, so 11 minus 3 is going to be 8. 8 multiplied by 2 is 16, and 16 multiplied, so it's going to be plus 16 multiplied by minus 5 over 3. And this is going to be the beginning of the end of the question. So half. Now 15 to the power of 2, it is going to be 225 plus 64, which is going to be 289. And the square root of 289 is going to be 17. So it is going to be 1 over 2 multiplied by 1 over the square root of 289, which is going to be 1 over 17. And then over here, 16, okay, there's no way to simplify it over here. Basically, we need to multiply 16 by negative 5. So 16 multiplied by 5 is going to be 80. And 80 divided by 3 plus 30, which is going to give me 56.6. So now we're going to multiply 2 times 17, which is going to be 34, and then 56.6 divided by 34 is going to give me 1.66. Now we don't need to forget the units over here because dz is basically meters per second in this case. So yeah, I believe the hardest part about this question is actually the calculation, and especially because I don't have a scientific calculator with me right now. But yeah, basically. Now, the other question over here, they're telling me a man whose height is 5.5 feet is walking away from the base of a street light along a straight path at a rate of 3 feet per second. If the height of the street light is 14 feet, what is the rate at which the person's shadow is lengthening? Now, in every single related rates problem, you have to find a way to relate the variables that are present in the question. So first of all, if you look at this problem like this, you can notice over here that you're creating a set of 2 similar triangles. So let's say that the height of the street light is going to be 14. So we're going to write it over here, 14 feet. The height of the guy is basically 5.5 feet and feet. Let's say that the distance from the street light to the guy is x, and the distance of his shadow is s. And in the question, they want us to find the rate at which the person's shadow is lengthening. So we want to find ds over dt. Now, using the similar triangle theorem, which is basically the similar triangle ratio over here, we can literally say that 5.5 over the total height of the street light, which is basically 14, is equal to the length of the shadow over the total length that you have over here, which is basically s plus x. So now we are able to find s in terms of x in this case. So we're going to cross multiply. We're going to get 14s equals 5.5s plus 5.5x. Now take the s to that side, so you're going to get 14s minus 5.5s is equal to 5.5x. Now 14 minus 5.5, it is going to be 8.5. So 8.5s is equal to 5.5x divided by 8.5 divided by 8.5. So 5.5 divided by 8.5, it is going to be 0.64. Or let's just keep it as a fraction over here. There's no problem whatsoever. So basically we have this relationship over here between s and x. So now deriving this equation, we're going to get ds over dt. It is going to be 5.5 over 8.5 dx over dt. But we do have our dx over dt, which is basically 3 feet per second, because they told us that he's walking away from the base of the street light along a straight path at a rate, say, 3 feet per second. So now instead of the dx over dt, I'm going to change it to 3. So now 5.5 over 8.5 multiplied by 3, which is going to be 0.64 multiplied by 3, and it's going to give me 1.94 feet per second. Yet another simple question. Now in this question, they asked us to find the value of the constant k. They told us that the side and diagonal of this rectangle above are strictly increasing with time. At that instant, when x is equal to 4 and y is equal to 3, dx over dt is the same as dz over dt, dy over dt is equal to k dz over dt. What is the value of k in this instant? Now, if you're looking at this triangle, I don't know about you, but the first thing that caught in my mind when I saw this problem is Pythagorean theorem. Because over here, they are telling me that x, y, and z are a function of time, and all of these variables are increasing. So the only way to relate all of these variables together are through Pythagorean theorem. So the Pythagorean theorem states that z to the power of 2 is equal to x to the power of 2 plus y to the power of 2. So this is going to be very easy for me to relate all of these variables together. But before we do that, notice that in the given information, they gave me the value of x and they gave me the value of y, but they didn't give me the value of z. So I'm going to go ahead and find the value of z before I do any deriving and any solving. So it is going to be 4 to the power of 2 plus 3 to the power of 2, which is going to be 16 plus 9. And so z to the power of 2 is going to be equal to 25. So z is going to be the square root of 25, which is basically equals to 5. Now, of course, algebraically speaking, it is basically technically plus or minus 5. But since we're talking about distances, we're just going to neglect the negative number and we're just going to focus on positive 5. Since there's no unit, I'm not going to use any unit over here. So now proceeding with the question, it is easier for me to find the rate over here because deriving this equation, you're going to get 2z dz over dt. I'm not going to write z prime in this just to, I don't know, change. 2x dx over dt plus 2y dy over dt. Now they told me that dx over dt is actually dz over dt, so I'm just going to use that. And they told me that dy over dt is equal to k dz over dt. So basically it's equal to 2x dz over dt plus 2y. And instead of dy over dt, k dz over dt. Now I have my z over here. Okay. Now z is basically equal to 5, x is basically equal to 4, y is basically equal to 3. So let's get started with it. 2 times 5 is going to be 10. dz over dt equals x is basically 4. So 4 times 2 is going to be 8 dz over dt. And the y is basically 3. So basically it is going to be 3 times 2. It is 6k dz over dt. Now notice over here that on this side the coefficient is 10 and on this side it is 8 plus 6k. So you can literally create an equation out of this and you can literally say that 8 plus 6k is equal to 10. So 6k is equal to 10 minus 8, which is 2. So K is going to be, hold on, the pen stopped working. So K is equal to 1/3, because 2/6 is the same as 1/3. I guess the pen doesn't write over here. It does. Anyway, sorry for the time wasting. So K is basically equal to 1/3. Now, in this question, they told us that an object moves along the x-axis so that its position at time t bigger than 0 is given by s of t, and ds over dt is basically negative 10t to the power of 4 plus 9t to the power of 2 plus 8t. When is the acceleration of the particle equal to 0? So we know that the derivative of a position is velocity, and the derivative of a velocity is acceleration. So if we're going to say that this is going to be our v, we basically want to find the derivative of v. So dv over dt, which is basically my acceleration, it is going to be minus 40 t to the power of 3 plus 18t plus 8. And they want me to find when is this acceleration equal to 0. Now, using a scientific calculator over here, basically you can use your I think it is mode 5-4. If you use mode 5-4, then you're going to go to your cubic calculation. So negative 40 is going to be multiplying my t cubed. There is no squared, so basically you're going to write 0. C is going to be 18 and D is going to be 8. So since you calculate, there's going to be 2 complex solutions and only 1 real solution. The real solution is basically 0.83106. So I'm just going to make a shortcut and say that it's equal to 0.83 seconds. All right, now the final question over here. The position of an object moving along a line is given by x of t, 2t cubed minus 24t squared plus 90t plus 7, for t is bigger or equal to 0. For what values of t is the speed of the object increasing? Now, we need to establish a concept that is like highly misconcepted by students. When you have a function, let's say that this graph represents like velocity or position, whatever it is. When the graph is going up, we say that f is increasing. But when we say that f is increasing, this literally means that f prime is strictly positive. And when f is going down, like when f is decreasing, this strictly means that f prime is negative. So when they're telling me that the speed of the object is increasing, they're telling me that the velocity is increasing. But according to the concept I wrote for you over here, if velocity is increasing, that means that the derivative of velocity, which is my acceleration, is positive. So now I don't just need to derive x of t once, but twice. So v of t, which is basically my x prime of t, it is going to be 6t squared minus 24t plus 90. So that is going to be my velocity, but I don't need my velocity. I need to go further. I need to go to my a. So my acceleration a of t, which is basically v prime of t, which is basically x double prime of t, it is going to be 12t minus 24. Now, when is this positive? It is positive when 12t is bigger than 24. It is positive when t is bigger than 24 over 12. It is positive when t is bigger than 2. And that, ladies and gentlemen, is the end of our session today. Please pause this video, like, subscribe, comment if you have any questions, or comment if you need any other material that needs to be covered in calculus. And thank you so much.